Mahle, a major auto parts supplier, claims to have developed the perfect electric motor by combining two innovative concepts from previous prototypes. The first concept, introduced in 2021, is the MCT, magnet-free contactless transmitter motor, which eliminates rare earth magnets in the rotor, reduces material costs, and operates with high efficiency through contactless induction. The second concept is the SCT, superior continuous torque motor, unveiled in 2022, which features a groundbreaking cooling system. It efficiently cools the motor, allowing it to operate at 93 to 100% of its peak power continuously, eliminating the need for oversized motors in high-temperature conditions. Mahle has now combined these two concepts to create a new unnamed motor that retains the advantages of both. It offers extreme efficiency, sustained high performance without overheating, long lifespan, and the ability to harvest heat, all while using no permanent magnets, which makes it cost-effective. Mahle is showcasing this motor as a technology toolbox for original equipment manufacturers, OEMs, at the IAA Mobility Expo in Munich. However, ZF Friedrichshafen, an automotive supplier, has developed a compact magnet-free electric motor for electric vehicles, EVs. This motor, named in-rotor inductive excited synchronous motor, I2SM, integrates the inductive transmitter into the rotor, saving space and eliminating the need for physical brushes or rings to transmit electricity to the rotor coils. By replacing traditional magnets with electrical windings in the rotor, ZF aims to reduce the environmental impact and supply chain disruptions associated with rare earth materials used in magnets. The I2SM offers power and torque density comparable to permanent magnet synchronous motors (PSMs) commonly used in EVs, making it a viable alternative. ZF claims that the I2SM can operate more efficiently than a PSM during continuous high-speed operation, such as highway driving. ZF plans to integrate the I2SM into 400-volt and 800-volt electric drive platforms for passenger cars and commercial vehicles, with the goal of achieving production readiness. Driven Technologies, a Colorado-based startup, has developed the Orbit Drive, a continuously variable transmission system for e-bikes. The Orbit Drive integrates two electric motors, a control computer, cadence and torque sensing, pedal cranks, and various power transfer options to the rear wheel, shaft drive, belt or chain. Benefits of the Orbit Drive include up to 20% more battery range than existing e-bikes, low maintenance for 10,000 miles, lighter weight compared to conventional drive systems, and a sleek, modern look with no exposed parts. The drive system can be adapted to fit different frames and batteries, offer regenerative braking, requires no adjustments, and aims for an aggressive wholesale price point. One potential drawback is that if the system is in its lowest gear and the gear ratio motor fails, the bike may be stuck in a low gear when the battery runs out. Driven Technologies is still seeking funding for further development and expects to enter the market by the Northern Hemisphere summer of 24. Continental has introduced a concept tire called the Conti CityPlus, designed for urban use with a focus on stop-and-go traffic. The tire addresses the issue of tire deformation during braking and acceleration, which is particularly relevant for heavier vehicles like electric vehicles, EVs. To reduce deformation, the Conti CityPlus features a stiffer carcass with added rigidity to the sidewalls. Specially formulated fillers, rubber, and polymer compounds contribute to reducing deformation and enhancing tire performance. The tire's tread pattern is designed for improved traction and quicker stops. Continental claims the Conti CityPlus offers a 10% improvement in tire efficiency, potentially resulting in a 3% increase in range for an EV, equivalent to saving 0.6 kilowatt-hours over 100 kilometers of stop-and-go driving. There is no specified production timeline for the Conti CityPlus concept, as it needs to undergo EU safety testing before becoming commercially available. IBM and Fujifilm have collaborated to develop a 6th-generation tape storage system capable of storing a record-breaking 50 TB of data. This tape storage technology is a significant advancement, despite the common perception that tape-based storage is outdated. Tape storage is still used in server farms for backup purposes, due to its advantages, including cost-effectiveness, large storage capacity, portability, and security. The newly developed tape is designed for IBM's 3592JF tape cartridge, used in the TS1170 drive, with a native capacity of 50 TB and a compressed capacity of 150 TB. It employs nanoparticle technology and fine hybrid magnetic particles, including strontium ferrite, SiF, and barium ferrite, BAF particles to achieve higher storage capacity per square inch and a larger recording area. The tape is 15% longer, thanks to a thinner and stronger base film to support the magnetic layer. This development demonstrates the viability of tape storage for data protection, active archives, and long-term retention in various environments, including scientific data, industrial data collection, and cloud services. Scientists at the U.S. Department of Energy's Oak Ridge National Laboratory, ORNL, have developed a novel method for visualizing air leaks in homes to assess their airtightness. The current standard method for assessing air leaks in homes is the blower door test, which involves using a fan to lower indoor air pressure, causing outside air to flow in and be detected using tools like infrared cameras or smoke pencils. The ORNL scientists sought a simpler and less invasive alternative and turned to a 159-year-old technique called Schlieren photography, which can visualize fluid flow. They used Schlieren photography to detect temperature differences in leaking air and created a shimmering pattern visible via an ordinary video camera. The system has been successfully tested on various building materials under different lighting conditions, requiring an air temperature difference of 12 to 15 degrees centigrade, 22 to 27 degrees Fahrenheit, with hopes to reduce it to 5 degrees centigrade, 9 degrees Fahrenheit. This new method shows promise for quantifying air leaks in homes more easily and effectively, potentially simplifying the process of assessing a home's airtightness. InMotion, a Chinese e-mobility specialist, has unveiled the adventure electric unicycle, designed for off-road exploration. The unicycle features a powerful 4,000-watt off-road motor, capable of peaking at 9,000 watts, designed for climbing 50-degree inclines with 200 Nm of torque and 850 N of traction force. It can reach speeds of up to 110 km per hour, 68.35 miles per hour, and accelerate from 0 to 50 km per hour in 2.5 seconds. Two ride modes are available: comfort mode for extended battery life and sport mode for higher power and responsiveness, customizable via a companion app. The unicycle has a reported range of 120 km, 75 miles per charge, with fast charging options available. It features a 16-inch wheel with 3-inch wide off-road tires, waterproof wheel assembly, and IPX7 sealed battery. The adventure model incorporates a custom progressive spring suspension with adjustable damping for comfortable and off-road riding. Additional features include anti-slip foot plates, a 1,500 lumen headlight, and automotive-grade taillights. The early bird retail price for the adventure electric unicycle is set at $3,299. The UGOT robotic kit, developed by Hong Kong robotics company UGOT, allows users to build multiple types of robots. It consists of modular components for functions like data processing, locomotion, sensing, and interfacing, allowing users to create various robot configurations. The kit includes options such as a quadruped robot, a self-balancing two-wheeled robot, a robot with omnidirectional mechanism wheels, a spider-like robot, and more. The robots feature electronics like a 720p camera, microphone array, IMU speaker, and touchscreen display. Users can pre-program the robots using Python or control them remotely via Wi-Fi or Bluetooth through an app. The app offers features such as bidirectional voice communication, FPV control, video photo recording, autonomous following, and AI interactive games. Kickstarter backers can pledge $549 for a full kit. The oscilloscope watch combines a modern wristwatch with an oscilloscope and other electronic tools. The watch features a 1.28-inch LCD panel, 8 function buttons, analog and digital inputs for oscilloscope and logic analyzer modes, USB connectivity, and a battery with over a year of use in watch mode, or about 9 hours in oscilloscope mode. The device will be added to the Gabatronics web store.